Now we're recording. Okay. We've gone through the limit process of finding derivatives. You've been working on that homework. It's a long process, isn't it? Very tedious to do. And I didn't give you anything as simple as x to the fifth. Think about trying to find the derivative of x to the fifth. That means you're going to have to do Pascal's triangle out to the fifth row. So you're going to have 6 things there. It's going to be a lot to go through, isn't it? Hard? No, but long process. Well, I've written up here for you, these are some functions, and these are the derivatives of those functions. And what I want you to do is look at that and make an observation. Tell me how you can look at that now. In fact, I'm going to write one up here. F of x equals x to the 100th power. And you should be able to look at that now and know what f prime is. 100x to the 99th power. Now they just looked at that and knew that. Do y'all see a pattern to it? Because what is the derivative always? The derivative of x squared is 2x. We reduced the power by 1. And then we took this exponent down and made it the coefficient. So the old exponent becomes the coefficient, and we reduce the new exponent by 1. Well, what happened down here at 2x cubed? It became 6x squared. How did that happen? We take the 3 and by the coefficient that was in front of it to begin with, 3 times 2 is 6. We still reduce the coefficient by 1. So suddenly, did finding the derivative just become an awful lot easier? Okay. Much easier process once we know that. If you'll look on the first page of your notes here, these are rules for finding derivatives. Now, over the next 3 lectures, we're going to go through and learn what all of these are. For right now, I want you to just know that you can refer back to these if you have any questions. The one that we just talked about is right here, called the power rule. That's probably the most important rule that you're going to have. The power rule is what we just used. If we've got x to the 3rd power, we're going to make the 3 the coefficient and reduce the power by 1. Now, what happens if it's a constant number? If we've got just f of x equals a number, there's no variable there to go anywhere with. So the derivative of a constant number is 0. Now let's think about that from a graphical perspective. Tell me about the derivative. With the first lecture, I said derivative and this mean the same thing. What are those 3 things? Derivative and what? Slope and tangent line. Slope, derivative, rate of change, tangent, all of those mean the same thing. So derivative and slope is what I want you to focus on right now. So let's think about a constant line, -10. What does that line look like? If I want to graph that, it's this line right here, right? It's a horizontal line. Now talk about the slope of this then. The slope is 0 because this is flat, right? So it's flat, so we would expect the slope to be 0. The slope is 0, therefore the derivative is 0. Okay? So that's something you need to just get in your mind and get comfortable with that, because you're going to have problems that's going to confuse you because it's constant. But think of it graphically. If it's constant, it's flat, it's horizontal, the slope is 0. Now, let's just work through some problems, and I think all of these rules will be pretty straightforward to you. So let's look at these 2 first of all. Find the derivative of each of the following. The derivative of y equals 5. Y prime equals 0. Okay? Because think about that graphically. That means y equals 5. It's a line up here. Slope is going to be 0. What about f of x equals 0? 0. F prime is 0 also, okay? F prime is 0 also there, okay? So get in mind, here's a tricky one for you. F of x equals the square root of 2. What's F prime? 0. F of x equals pi. 0. Why?
Because they're all real numbers.
Pi is a real number. Pi is just, if we try to graph f of x equals pi, it's just a horizontal line. So the derivative is still 0. Okay? Well, what about that? Whoa. We didn't talk about that.
Yes, we did.
We did, but we don't know we did? Okay.
It's still constant.
Well, now we've got an x in it now.
X changes.
So can you think of another way to write 5 over x? Five times 1 over x, okay. That's not going to help us a lot, but
5x to 1/2.
what about that?
-1, not
What about 5x to the negative 1? Does that mean the same thing? If I take this x to the numerator, the exponent changes, right? The sign of the exponent changes. Well, now can I use the power rule to solve this? What does our rule say? We're going to take this power, negative 1, make it a coefficient. So I'll keep the 5. I got a negative 1. X, we're going to reduce that power by 1. Negative 2. X to the negative 2. And that, how would that look? That would be negative 5 over x squared. Now go back and just think about, you worked 2 or 3 problems like this last night. Doing it by the definition takes a long while, doesn't it? Okay? This is the simpler way to do it here. As long as you can realize moving that x up, suddenly life gets real easy there. Doable? Much nicer there. Okay, good. Well, I've got several examples here that are going to be similar to one another. See what you can do with that. I'll give you 30 seconds. See what you can come up with for the solution, and then we'll talk about it. T to the what? Cubed. Okay. 20 over 7 t cubed. Now, oftentimes this is confusing for students because it looks like it's a fraction, right? Here's what I would do if it helps you. I'm going to rewrite this to be 5 over 7 times t to the 4. Is that the same thing? If I multiply these together, I can still get to that, right?
But wouldn't the t still have to be? Why does the t not still have to be over 7? Why is that the same?
Yeah, I don't understand that either.
Okay, if we're going to multiply these two things, we'd multiply the top times the top. 5 times t over 4 would give me 5t to the 4th. 7 times 1 would give me the 7. So I've got to have a 7 either in that fraction or that one. Either way, when I multiply it back together, I get the 7 up there. If I put a 7 here, 7 times 7 would give me 49 back up there.
Okay.
Does that make sense? You're thinking add. If I'm adding, I got to have the same denominator. Yeah, but I'm not adding.
Wrong to write 20t cubed over 7.
That's where we're going to get to. If you can see from there to get here, that's fine. I'm just showing you, if you're having trouble there, write it like this. So now what do? Well, now then the derivative is 5/7 times 4t cubed. And how do we multiply 5/7 times 4? We multiply numerators together. 5 times 4 is 20 over 7t cubed. All right? Is that hard to do?
Okay, so the t cubed can't be on the line.
The t cubed can either be out beside, the t cubed can be considered in the numerator. The t cubed is not in the denominator. Yes. The t cubed can be in the numerator, yes. It cannot be in the denominator. Yes, it is.